Oh, drat these computers. They're so naughty and so complex. I could pinch them.
What's up, everyone, and welcome. In this episode, we're going to talk about the Siloscape Kubernetes Backdoor. Siloscape is a heavily obfuscated malware targeting Kubernetes clusters through Windows containers. Its main purpose is to open a backdoor into poorly configured Kubernetes clusters in order to run malicious containers. With so many companies moving to the cloud, and with Kubernetes now the de facto standard for managing containerized workloads and services, and widely used by a growing number of enterprises to underpin their cloud-native applications, this new hack is an extremely serious threat. This threat was found by Daniel Prizmant from Unit 42 and his team. I'd love to get him in an interview because I have a ton of questions for him. Let's see if he takes me up on my invitation. Siloscape is what we're going to take a look at today, along with steps to take to avoid this happening to any system you control. The agenda for today starts off with a definition. What is Siloscape? In order to build a good defense, we must intimately know our enemy. We're going to move on to the anatomy of the attack. How does it work? If we know the pieces and how they work, we can evaluate where we are vulnerable. We're going to end up with what can I do? Steps to improve. We're going to look at how we can implement measures to either fix for good and or continuously scan systems to ensure it does not happen again. Let me take a minute to give you some powerful reasons why you should share this video. Now, if you have seen this before, feel free to skip to the next section or just enjoy it again. If you haven't seen it yet, I want to show you how you can be a superstar in your team and your company just by sharing this video. First off, I really appreciate you watching this episode, liking it, and of course, subscribing to my channel. But I ask you to share it through any and all channels you have access to, whether Facebook, Twitter, LinkedIn, YouTube, Pinterest. You can link to it from your websites or even send it in an email to your colleagues, friends, and family. If we can spread this information to enough people, we all together can work to make the internet more secure. So, share it with developers in your team or developers that you know so they can integrate the security measures I will outline in this episode directly into their workflow. Share it with quality testers in your team or ones you know so they can benefit from this information and improve things like writing their acceptance criteria and test cases. Share it with project managers and product owners so they can make sure projects have the right security principles in mind and can talk intelligently to stakeholders about the importance of these measures. Share it with CEOs, VPs, and managers to show them that you're on top of these topics, taking them seriously, making you look like a superstar in their eyes. And finally, share it with your mom, dad, grandma, or friends, or anyone you can think of. Keeping them safe and helping them have a safer experience on the internet will definitely save you time and headache. Now, if you haven't already, right now is the perfect time to pause this video and share it before we really get deep into the content. Thanks again for your support. What is Siloscape? Siloscape is an obfuscated malware that targets Windows containers and from there attempts to open a backdoor into poorly configured Kubernetes clusters where it runs malicious containers. The newly identified malware dubbed Siloscape, found by threat researcher Daniel Prizmant from Unit 42, appears to be the first recorded malware to target Windows containers and presents a potential risk to badly configured enterprise clouds. Prizmant said that the emergence of a malware targeting Windows containers was unsurprising given the surge in cloud adoption in the past few years. He named it Siloscape because its primary goal is to escape the container, which in Windows is implemented mainly by a server silo. Compromising an entire cluster is much more severe than compromising, say, an individual container, as a cluster could run multiple cloud applications, whereas an individual container usually just runs a single cloud application. For example, the attacker might be able to steal critical information such as usernames and passwords, an organization's confidential and internal files, or even entire databases hosted in the cluster. Such an attack could even be leveraged as a ransomware attack by taking organizations' files hostage. Even worse, with organizations moving to the cloud, many use Kubernetes clusters as their development and testing environments, and a breach of such an environment can lead to devastating software supply chain attacks. just think back to my episode on the CodeCove Bash Uploader tool. If you haven't seen it, I highly suggest you go back to my channel and check it out. It was a supply chain hack that had CodeCove supplying customers with malicious software inside their legitimate product. Imagine if companies use Kubernetes clusters to host their dev environments to build their tools or services, and then they get compromised. Using this attack, a hacker can gain access to the Kubernetes environment. They can inject their backdoor and other malicious code into your development project pipeline or the build process, so that when you build and provide your software for customers to use, the software you're distributing already has a hack or a backdoor in it. Siloscape could be, after all, a backdoor as a service, which we'll see in the next slide. This malware can leverage the computing resources in Kubernetes cluster for cryptojacking and potentially exfiltrate sensitive data from hundreds of applications running in the compromised clusters. Investigating the command control server showed that this malware is most likely just a small part of a larger network, and that this campaign has been taking place for over a year. In the course of his research, Prizmant also gained access to the service. Now, this is a smart guy, and he's got a really smart team. But I think he actually also got lucky to find the server or find the connection and then actually gain access to it. Nonetheless, kudos to him. Great job. He and the Unit 42 team found evidence of 23 active victims and found that the server was hosting a total of 313 users, which again indicates that Siloscape sits as just one element of a much broader, long-running campaign of cyber attacks. Here's a screenshot showing how he was in their system, and after about an hour, they noticed him and booted him out. Now, I wonder what all the 313 users were doing. I highly doubt that they're all doing the same thing, or all maybe even part of the same band. Could each one of the users, or even groups of them, be using the backdoors on different systems, aka, or in other words, the 23 active victims, to be applying different ransomware, cryptojacking, and malware attacks? Again, kind of indicates that this is a backdoor as a service for me. Now, the issue of breaking out of the silo was reported by Prizmant to Microsoft, and according to Prizmant, Microsoft first said this issue was not a problem because Windows Server containers aren't a security boundary. Ergo, each app running inside such a container should be treated as though being executed directly on the host. But after taking the issue to Google and following some back and forth between the two, Microsoft changed their mind and said an escape from a Windows container to a Kubernetes cluster, and they added, when executed without admin rights inside the container, was indeed a vulnerability. From there, it was a short leap to the discovery of Siloscape, according to Prizmant. Now, Prizmant reiterated that unlike most cloud malwares that confine themselves to activities such as resource hijacking or denial of service, Siloscape should be considered especially dangerous because it's not limited to specific goals and can be used for many other kinds of attacks. So, in essence, this Siloscape opens a door and gets you access to the system. So then any other type of attack or action can be taken on the system. If you think back to my episodes on black cocaine ransomware, where it's still not known what the initial infection vector was, it could potentially be Siloscape. Now, if you haven't watched that episode, I recommend you go back to my channel, check it out. Or my episode on Epsilon ransomware, where with the red.exe, it was a simple application that sort of outsourced most of the work to PowerShell scripts. So it basically tunneled through whatever the request was to PowerShell scripts. Who knows? Maybe these groups, Epsilon ransomware and the creator of this backdoor kind of got together, learned from each other, and then came up with this new improved backdoor where all this does is really take commands from the command control center and execute them on the system. Acts as a tunnel for the commands. Or you can look at my episode on Revel or the one I did on Ragnar Locker or any other Windows-based ransomware malware attack. They could all be delivered and executed via this backdoor. So there's no specific need to, go up on your own and exploit something, look for exploits for like Microsoft Exchange Server, since through this backdoor, the attacker already has access. So again, with 313 users and 23 active victims, I ask, is this a backdoor as a service? So how does it work? If you take a high-level look at how it works, it's as follows. It first targets common cloud apps such as web servers and accesses them via known vulnerabilities. It uses the Windows container escape technique to escape from there to gain code execution on the underlying node. Then it attempts to abuse the node's credentials to spread further through the Kubernetes clusters. Basically try to create new nodes within the cluster. It then uses the Tor proxy and a .onion domain to connect back to its command control server to receive further commands. So here is a schematic that was provided by Unit 42. Now, before we dive deeper into the actual technical nitty-gritty details of Siloscape, it's important to get a better understanding of its overall behavior and flow. This gives you a extremely good look, but I have two small issues. One is it's static, and there's a lot of information in here. There are a lot of arrows and things going around that it's kind of hard to focus. The second issue I have is that they put the fifth step here, or at least the number 5 here, as if it's the cloud-malware.exe connecting to the command control server. However, the written steps indicate that step 5 is the search for kubecontrol.exe and config. So 5 for me should really be here. So as a pet peeve, and how I like to kind of make it more interactive, I redid their schematic. Hope they're not mad. So here I have my Kubernetes cluster with one node, one Windows node, and I have my attacker, and my attacker has his command control server already set up. Now, he finds some vulnerability near your server, and he achieves remote code execution inside the Windows container using this known vulnerability, or like a vulnerable web page, or database, or Microsoft Exchange, or whatever. He then drops his cloud-malware.exe application onto the system, and he runs a command. So he executes the Siloscape cloud-malware.exe with the necessary command control server connection information provided as command line arguments. So they're not hard-coded inside the binary. Here I have an rudimentary example of calling the command cloud-malware.exe. Now, he states later in his research that the first argument is either a string or a decryption key to one of two keys. The one that's passed in the argument, and then there's one that's actually hard-coded into the binary, that are used to decrypt the password for accessing the command control server here. So you have cloud-malware.exe, and then the decryption key for the password, or one of the two decryption keys for the password. Then you have the onion domain. I'm not sure about this order afterwards, but I'm just trying to throw it out there, that it definitely passes the onion domain to where this command control server lives. It also must pass something like username, and then an encrypted password with it. So once that is started, then the next processes happen where Siloscape impersonates the C execute service.exe to obtain set CB privileges on the system. So it needs to set the privileges, kind of give the user elevated privileges on the system, so that it can then create a symlink between the containerized X drive and the host's C drive. Once it has that, it executes a search, which would be the step 5, and kind of where I vie from the chart or the schematic provided by Unit 42. It executes a search, so it types in the search command here, and because of the symlink, it is executed on the host C drive to look for the kubecontrol.exe, and it looks for that by its actual name, as well as the Kubernetes configuration file, which it uses a regular expression to find. Once it finds that, it says, okay, so I found where the kubecontrol.exe file is located, and I know where the configuration file is. It then executes a command to see whether or not it can create other nodes. It wants to see if it can use this information here to create new nodes where it could then inject some kind of application or whatever other function or actions it wants to do. It wants to spread itself. And here is the command that would be used. It's key to note that once it finds these, it sets them as environment variables that it can then pull in here. So this would be replaced with kubecontrol.exe. So it's kubecontrol.exe auth can I create deployments with the kube configuration location as being the second variable passed in here. Once it can execute that, it then goes back to the binary. It rips a zip file of the Tor client out of the binary, as well as a unzip binary, installs those. Once it's installed, Siloscape connects to the Tor network. So it basically opens up the client to allow it to connect to the Tor network. Now, using the command line arguments, specifically the decryption key for the password, it decrypts the command control server password, and then it connects to the command control server. So it now has the connection to the command control server. It is now installed on your system. It's now set up on your system. It knows that it can replicate itself or create new nodes which would have any type of application, ransomware, cryptojacking, etc. implemented into them. And then it just sits there and waits for commands from the command control server that it can execute, whatever they be. Now, unlike other malware targeting containers, which are mostly cryptojacking focused, Siloscape doesn't actually do anything that will harm the cluster on its own. Instead, it focuses on being undetected and untraceable and opens a back door to the cluster. So again, this thing just sets up the base for somebody else who's on this command, those 313 users, to do whatever they want to do inside of here. So, if you look at sort of how it hides itself, its evasion and obfuscation, it is heavily obfuscated. There are almost no readable strings in the entire binary. Even simple API calls were obfuscated, and instead of just calling the functions, Siloscape made the effort to use the native API version of the same function. So, for example, instead of calling createFile, Siloscape calls ntCreateFile. And even further, instead of calling ntCreateFile directly, Siloscape calls it dynamically, meaning it searches for the function name in ntdll at runtime and jumps to its address. Not only that, but it also obfuscates the function and module names and deobfuscates them only at runtime. The end result is malware that is very difficult to detect with static analysis tools, and as Prizmant put it, frustrating to reverse engineer. Now, if we want to go back to the decryption of the password, Siloscape uses a pair of keys to decrypt the command control server's password. One of the most important features of its obfuscation is that one key is hard-coded in the binary, while the other is supplied as the command line argument. Now, Prizmant searched for its hash in multiple engines, such as autofocus or VirusTotal, and he couldn't find any results, which would indicate that Siloscape is being compiled uniquely for each new attack using a unique pair of keys. The hard-coded key makes each binary a little bit different than the rest, which explains why the hash from any one binary can't be found anywhere. It also makes it impossible to detect Siloscape by hash alone. Another interesting technique is that this malware uses Visual Studio's Resource Manager. This is a feature built into Visual Studio that allows one to attach basically any file to the original binary and get a pointer to its data with a few simple API calls. Siloscape uses this method to write the Tor archive to the disk, as well as the unzip binary used to open the archive. It also uses Tor to securely connect to its command control server, as I mentioned before. If you want to look at the container escape method, as one of the more interesting things about Siloscape is the way it escapes the container. To execute the system call NT-set-information symbolic link, which is how it creates, if you remember for the chart, the diagram I showed you just earlier, they created a symbolic link from the X drive to the C drive of the host. You use NT-set-information symbolic link for that. One must gain setCB privilege first. Now, there are a few ways to do this. For example, in Prizmant's tests, he injected a DLL into the cexecute service.exe, which has the relevant privileges, and then executed nt-set information symbolic link from cexecute service.exe context. Siloscape, however, uses a technique called thread impersonation. This method has little documentation online and even fewer working examples. The most critical function for this technique is the undocumented system call nt-impersonate thread. Siloscape mimics cexecute service.exe privileges by impersonating its main thread, and then calls nt-set information symbolic link on a newly created symbolic link to break out of the container. More specifically, it links its local containerized X drive to the host C drive, as we saw in the diagram. Now, searching for the files. After Siloscape creates a link to the host, it searches for the two specific files I mentioned earlier, kubecontrol.exe and config file, which were step 5, which normally exists on Kubernetes nodes. Again, all the code is obfuscated, but you can see when it's deobfuscated, the find file, it's being added to the X drive, which is then siphoned or passed through to the C drive, kubecontrol.exe. Siloscape searches for kubecontrol.exe by name and the config file using a regular expression, as I mentioned before. The search function takes an extra argument, a pointer to a vector, that holds folder names to exclude from the search. So when it calls find file to search for the files, it excludes folders, programs, program files x86, Windows, and users. It does this to make the search faster, and because it's unlikely that the previously mentioned files are in those folders. If both folders are found, their paths are saved to a global variable, as I showed you in the execution command within the diagram here, and then it swaps out these variables, these placeholders with the variables for kubecontrol.exe and the location of the config file. But here's a key point. If the files are not located, Siloscape exits, abandoning the attack. So after Siloscape finds everything it needs to execute kubecontrol commands, it continues to check if the compromised node actually has enough permissions to use for the attacker's malicious activities. It does this by executing the kubecontrol command, kubecontrol.exe auth cannot create deployments, kubeconfig file equals the location of that file, where the strings in the format are replaced by the paths it saved earlier as global variables. Third time I said this. Now, here are things that I don't see in the research paper that I find extremely interesting. And again, if I could get an interview with Mr. Prizmant, I would love to ask him these questions, and as well as others, to find out even more about this particular backdoor. So the first thing I ask is, what's the build of the exe? So, for example, is it like the others that we're seeing in ransomware attacks? It uses the Go language, it's 64-bit build, it's using Ming GW tool. Then the research does state that it is more of a command execution program instead of a goal-specific malware like cryptojackers or ransomware. But it would be interesting to know if there are any other commands inside of there, or if it uses like PowerShells, or if it disables antivirus, or it disables a firewall, or if it maps local network drives. Kind of recon work and pre or setup work for whatever attacks might be coming through. So that the malware or the ransomwares may not need to do it. It's already pre-done for them. It'd just be interesting to know that. So we know that hacking and ransomware attacks are evolving at a mind-numbing pace, and these attacks are becoming more of a modular system, where you can take a piece from this group and match it to a piece from another group and build a new ransomware. So knowing things like what I listed above could shed light on the different ransomware networks and teams that may now be banding together to attack companies. So here are some specific things, specific to-dos for this attack. Users should follow Microsoft's guidance recommending not to use Windows containers as a security feature. Microsoft recommends using strictly Hyper-V containers for anything that relies on containerization as a security boundary. Any process running in Windows service containers should be assumed to have the same privileges as admin on the host, which in this case is the Kubernetes node. If you're running applications in Windows Server containers that need to be secured, they recommend moving these applications to Hyper-V containers. Finally, administrators should make sure their Kubernetes clusters is securely configured. In particular, a secured Kubernetes cluster won't be as vulnerable to the specific malware as the node's privileges won't suffice to create new deployments. So if you remember, they were trying to spawn off new nodes, but if you're using a securely configured Kubernetes cluster, then the node itself would not have enough privileges to then create or duplicate itself or create other nodes. So in this case, Siloscape would exit because it can't create new nodes. Here's some general steps you can take. You've most likely seen these in my other episodes. You want to educate your users. And in this case, it would be system admins or anybody responsible for dealing with any individual node or application on the node, on those nodes. You want to educate them to spot suspicious emails, activity on any system, and contact either the security department or IT if they encounter anything suspicious. You want to make time for regular offline backups, and you want to test those backups to ensure they can be restored from reliability. Offline does not mean somewhere on the network still connected to the network. Offline means offline. Offline means there is no direct path to access the system or the backup drive or whatever it is that has this on there. It's outside of your network or offline or shut off. You want to have a plan and review it regularly. Systems change, requirements change, environments change, new vulnerabilities arise. So you want to have a plan about, how you're dealing with this stuff, how you're setting up your systems, how the system works, so that you know exactly how you need to react or what might be vulnerable, be able to pinpoint which systems particularly run a specific software if a new vulnerability comes out. You want to review your infrastructure, your hardware, your software regularly. Of course. You want to update systems regularly. I shouldn't have to put this in there, but I do. Restrict write permissions, especially on things like file servers. Use advanced endpoint protection that can identify new malware variants and detect malicious traffic. Use email and web protection to block access to malicious websites and scan all downloads. As we saw, that there really is no known way of how this initial infection is done within the schematic and within a few of the notes from the researcher. They say, okay, they exploit a vulnerability on the server itself, but that's not the only way these people are getting in your systems. They could be sending a malicious email that leads you to some website that has a malicious script on it that then infects your machine, and then because your machine, if you're one of the developers or system admins, has access to the Kubernetes system, then that's how they get in. Or they can get in. You want to use at least a 2 firewall based system. Some circumstances, I would say you would want to use even more. External network firewall as a minimum, as well as a local machine based software firewall. In the case of, let's say, a database or a file server that has very sensitive data, you might want to put a secondary hardware firewall in right after your switch to further secure that. You want to restrict outgoing connections where possible. This will or could limit the ability for these attacks to contact their command control servers. Now, this particular point could be moot if, for example, within my questions I have things that I did not see within the research. This particular backdoor or this attack attempts to or successfully disables the software-based firewall on the node itself. However, if you had a hardware-based firewall in front of your entire systems, and then hardware-based firewall were also restricting connections, then you could restrict the access to either Tor network domains or traffic that's not necessarily required from any individual system. You want to disconnect from the networks immediately if you suspect infection. Goes without saying. You don't need to sit there with your jaw dropped and let all the systems be infected. As soon as you see something, or as they say in the New York public subway, if you see something, say something. Right here, if you see a system acting weird, shut it down, turn it off, unplug it, rip out the plugs, whatever, until you can really wrap your head around what's going on. Finally, if you can, get insurance. Highly recommend it. If you look at all of the ransomware episodes I have done for the companies that have paid, oftentimes a lot of it, if not all of it, was covered by insurance. So folks, thanks for your attention, and don't forget to share this video. I really appreciate you taking the time to watch this episode with me, join me on my journey, and I look forward to seeing you on the next episode. Take care.